as you can see, the theorem says that if capital X is the adjacency matrix of a simple graph, okay, we normally adjacency matrix represent capital X vachitana. For a graph capital G given, then the ijth entry in X raised to R is the number of different edge sequences of R edges between vertices Vi and Vj. So, first I'll take a small example. Okay, so if I have a small adjacency, I'm taking a small simple graph for a graph. Okay, let us name it as V1, V2, V3. I'll name this edges as A, B, and C. Okay, so I'll first end the first step and then adjacency matrix. Okay, X is the adjacency matrix. So adjacency matrix of the graph G. This is the graph G. And other than adjacency matrix in the parama, we have V1, V2, and V3. The rows and columns are the vertices V1, V2, and V3. So if you see V1 is incident with V2 and V3, V2 is incident with V1 and V3, and V3 is incident with V1 and V2. So remaining portion I'm going to put it as zeros. Then the ijth entry in X raised to R. Okay, X raised to R. X raised to R or ijth entry. Now, if I consider R in the value, let R value be equal to 1. Let us consider R value is equal to 1. So that is equal to X raised to 1, which is actually equal to X. Okay, X raised to 1, which is actually equal to X. Now, this is theorem explain. Then the ijth entry. Okay, if I take I to be 2 and J to be 3. Okay, if I take I to be 2 and J to be equal to 3, in my X raised to R, is the number of different edge sequences of R edges between the vertices Vi and Vj. So Vi is said to be V2 and Vj is said to be V3. So V2, V3 is 1. Okay, V2, V3 is 1. So you can have only how many edges, how many edge sequences the number of different edge sequences of R edges. R edges R in the value 1. Between V2 and V3 is only of type 1. That is V1, V2 and V3 namle length 1 ulla edges possible. This is possible. That is C. Okay, only C is said to be possible. If this path edges 2 but length R in the value 1 I need only 1. I'll have only one distinguished edge between V2 and V3, which is said to be having a length of 1. So C which is said to be of length 1, which connects V2 and V3. So this is proof. So with example, proof of induction. So you'll understand with that theorem concept. Okay. So first of all, as we write the proof, we will write that the proof is by induction. The proof is by induction on the value R. On the value R. Proof is by induction on the value R. Okay. So then we'll consider, you have to consider the graph G. You have to consider the graph G. Graph G in the example, the extended version to make things more easier. I have V1, I have V2, V3 and V4. Okay, I have A, D, B, C as my edges. So, in a graph corresponding I'll be having an adjacency matrix. I'll have an adjacency matrix. Okay, of the graph G is, how will you give X of G is equal to, which are the vertices V1, V2, V3 and V4. Here also you have V1, V2, V3 and V4. Okay. So, V1 the code incident the edges AD, which is connecting your V2 and V3. So you have V2 and V3. V2 edukumbam only V1 and V3. V2 edukumbam only V1 and V3 is said to be there. V3 edukumbam V3 is connected to V1, V2 and V4. V3 is connected to V1. Okay, it is connected to V1, V2 and V4. Okay. What about V4? It is connected only to V3. It is only connected to V3. So remaining area I'll put it as 0. This is important. നിങ്ങൾ ഈ ഒരു മെട്രിക്സ് തെറ്റിപ്പോയാൽ പിന്നെ അങ്ങോട്ടുള്ള എല്ലാം derivation will go wrong. So first thing is to prove it. First of all, we will do it on the value of R. Rന്റെ ഓരോ വാല്യൂ എടുത്തിട്ടായിരിക്കും നമ്മൾ ഈ സ്റ്റേറ്റ്മെന്റിനെ പ്രൂവ് ചെയ്ത് കാണിക്കുന്നത്. അപ്പോൾ നമ്മൾ എന്താ ചെയ്യണമെന്ന് പറഞ്ഞാൽ നമ്മളൊരു ഗ്രാഫ് കൺസിഡർ ചെയ്തു, അതിന്റെ ഇക്വിവാലന്റ് ആയിട്ടുള്ള മെട്രിക്സും നമ്മൾ adjacency മെട്രിക്സും നമ്മൾ ഡ്രോ ചെയ്ത് കഴിഞ്ഞു. Okay. Now you have to keep this adjacency matrix in mind. Only then we will be able to do the things. Okay. So keeping this in mind, first of all, we'll take the value of R. Okay, R is equal to 1. We will take the value of R. R is equal to 1. So I'm going to write let R is equal to 1. Let R is equal to 1. Then what did I say? Then x raised to R will be equal to x raised to 1, which is equal to x. Please remember, this is x raised to 1. So now what we need to prove? We need to prove that ijth entry in your x is the number of different is a number. I'm writing the same theory. Okay, theorem thannu njan ezhuva that ijth entry in x is the number of different edge sequence of length R is equal to 1 between your vertices Vi and Vj. Okay. So if I have to prove this, I have to take various examples. So for that, I'll keep my references V1, V2, V3 and V4. I have V1, V2, V3 and V4. So you will have the values as 0, 1, 1, 0. Then you have values 1, 0, 1, 0. Then you have 1, 1, 0, 1. This was just connected to V3, so 1. Okay, so this as a reference I have kept. So I'm saying that this is my x of g. Okay, so keeping this in mind, first I'll take let my I is equal to 2 and my j is equal to 3. My I is equal to 2 and my j is equal to 3. What is the value that you have? You have the ijth entry as ijth entry of x is said to be equal to 1. Okay, so your ijth entry, okay, in x is equal to 1. It is equal to 1. Now then what do you have to say? Then the number of different edge sequences of length R is equal to 1 between your Vi and Vj has to be what? It has to be 1. Then the number of edge sequences, I'm writing the same sentence, sequences of my length R is equal to 1. Okay, between what is Vi? It is V1 and Vj is said to be V2. Sorry, not V2, sorry. This Vi is said to be V2 and Vj is said to be V3. Okay, is said to be what? Is said to be equal to 1 because my x is said to be 1. I've got it as 1. That is this entry V2 and V3 is said to be 1. That's what I've written. So what is the example? If you see there, if you see this, V2 and V3 is connected only by one edge that is said to be V of length 1. Okay, നമുക്കിപ്പം V2 നെ V3 നെ കണക്ട് ചെയ്യാൻ വേണ്ടി പല രീതിയിൽ നമുക്ക് ചെയ്യാം. ഇപ്പം ഇങ്ങനെയും പോവാം, ഈ പാത്തിലും പോവാം. ഓക്കെ, ഐ ക്യാൻ കം ഫ്രം ദിസ് പാത്ത്, ബട്ട് അതിന്റെ ലെങ്ത് എത്രയാണ്? 2 ആണ്. ബട്ട് എനിക്ക് വേണ്ടത് ലെങ്ത് എത്രയാണ്? 1 വെച്ചുള്ള ഒരു എഡ്ജ്. ഓക്കെ, ലെങ്ത് 1 ഉള്ള ഒരു പാത്താണ് ഞാൻ കണ്ടുപിടിക്കുന്നത്. അതെന്ന് പറഞ്ഞാൽ ബി മാത്രമേ ഉള്ളൂ, വേറെ ഒരു എഡ്ജ് പാത്തും എനിക്കില്ല ബൈ വിച്ച് ഐ ക്യാൻ കണക്ട് V2 ആൻഡ് V3 വിച്ച് വിൽ ബി ഹാവിംഗ് എ ലെങ്ത് ഓഫ് 1. സോ ഇവിടെ ഈ എഡ്ജ് മാത്രമേ ഈ കണ്ടീഷനെ പ്രൂവ് ചെയ്യുന്നുള്ളൂ. It is only the edge B which is said to be proving this condition. That is, the connection between V2 and V3 should be of length 1. It should be of length 1 because my R is said to be 1. അപ്പോൾ അങ്ങനത്തെ ഒരു പോസിബിലിറ്റി മാത്രമേ നമുക്ക് ഉള്ളൂ എന്നാണ് നമ്മൾ ഈ അഡ്ജസൻസി മെട്രിക്സ് വെച്ച് മനസ്സിലാക്കി എടുക്കണത്. സോ ലെങ്ത് ആർ ഇസ് ഈക്വൽ ടു 1, ദാറ്റ് ഇസ് ഒറ്റൊരു എഡ്ജ് വെച്ചിട്ട് നമുക്ക് V2നെ V3നെ കണക്ട് ചെയ്യാൻ വേണ്ടി എത്ര പോസിബിലിറ്റി ഉണ്ട്? ഒരു പോസിബിലിറ്റി മാത്രമേ ഉള്ളൂ എന്നാണ് നമുക്ക് ഇവിടെ ഈ മെട്രിക്സിൽ നിന്ന് മനസ്സിലാക്കുക. ആക്ച്വലി ഈ മെട്രിക്സിൽ നിന്ന് മനസ്സിലാകുന്നത് ഇപ്പോൾ V1 V2 കണക്ട് ചെയ്യാൻ വേണ്ടി ഒരു പോസിബിലിറ്റി ഉള്ളൂ, നമുക്ക് ലെങ്ത് 1 ഉള്ള ഒരു എഡ്ജ് വെച്ചിട്ട് കണക്ട് ചെയ്യാൻ വേണ്ടി. V1 ഉം V3 കണക്ട് ചെയ്യാൻ വേണ്ടി ഒരു പോസിബിലിറ്റി ഉള്ളൂ, നമുക്ക് V1 ആൻഡ് V3 കണക്ട് ചെയ്യാൻ വേണ്ടി. ദാറ്റ് മീൻസ് ഒരു എഡ്ജ് എഡ്ജ് ഓഫ് ലെങ്ത് 1 വെച്ച് കണക്ട് ചെയ്യാൻ വേണ്ടി ഉള്ള ഒരു പോസിബിലിറ്റി മാത്രമേ ഉള്ളൂ. ദാറ്റ് ഈസ് വാട്ട് ഇറ്റ് മീൻസ്. ഓക്കെ, സോ ഹിയർ വാട്ട് ഇസ് ഇറ്റ്? ദാറ്റ് ഈസ് ഏത് എഡ്ജ് വെച്ച് നമുക്ക് കണക്ട് ചെയ്യാൻ പറ്റും? ദ ഓൺലി പോസിബിലിറ്റി ദാറ്റ് വി ഹാവ് ഈസ് സെഡ് ടു ബി യുവർ എഡ്ജ് B. Okay, the only possibility is said to be your edge B, which is said to be considered as true. Okay, ഇനി നമുക്ക് അടുത്തൊരു എക്സാമ്പിൾ എടുക്കാം. Now let us take, you have to prove with so many examples. At least minimum 2 to 3 examples വെച്ച് നമ്മൾ ചെയ്യണം ഓരോ കണ്ടീഷനും കൂടി. Here the R is said to be equal to 1 condition വെച്ചിട്ടാണ് നമ്മൾ ചെയ്തത്. Now let us consider that I value is said to be equal to 2. Okay, and your J value is said to be equal to 4. I value is 2 and J value is said to be 4. അങ്ങനെയാണെങ്കിൽ what is my ijth entry? What is my ith jth entry in X? അത് നമ്മൾ നോക്കുമ്പം 2, okay, and it's said to be 4, the value is said to be 0. That is, you have 0 possibilities. You have 0 possibilities of connecting V2 and V4 with a single edge. You have 0 possibilities of connecting V2 and V4 with a single edge because R in the value 1 ആണ്. അപ്പം V2 V4 എടുക്കുമ്പം V2 ആൻഡ് V4 എടുക്കുമ്പം ഡയറക്റ്റ് കണക്ഷൻ ഉണ്ട്. ഒരു എഡ്ജ് വെച്ച് കണക്ട് ചെയ്യാൻ പറ്റുമോ? നമുക്ക് പറ്റത്തില്ല. ഡയഗ്രാമിൽ തന്നെ നമുക്ക് ഗ്രാഫിന്റെ ഡയഗ്രാം വെച്ച് നമുക്കറിയാം V2നെ V4ന്റെ കൂടെ കണക്ട് ചെയ്യണമെങ്കിൽ എനിക്ക് മിനിമം 2 എഡ്ജ് എങ്കിലും വേണം. ഓക്കെ, മിനിമം 2 എഡ്ജ് എങ്കിലും വേണം. ആൻഡ് മാക്സിമം ഐ ക്യാൻ ഹാവ് 3 edges. ഓക്കെ, സോ ഒരു സിംഗിൾ എഡ്ജ് വെച്ച് ഡയറക്റ്റ് കണക്ഷൻ ബിറ്റ്വീൻ V2 ആൻഡ് V4 ഉള്ള പോസിബിലിറ്റി ഇല്ല. ദാറ്റ് ഇസ് വാട്ട് മൈ X is said to say. That is also true. That is also true. So you will say that ijth entry in X is said to be 0. So namukku etra minimum edges venam? This is said to be true, isn't it? This is said to be what? This is said to be true. Why? Because as we need minimum 2 edges, right? As we need minimum 2 edges between your V2 and your V4. Okay. Okay, so this was the second condition. Now let us take another one more example. Let your I is equal to 4 and your J is equal to 3. So I is said to be equal to 4 and your J is said to be equal to 3. So there's one possibility of connecting V4 and V3 with a single edge. R in the value 1 and the number of different edge and sequence of length R is equal to 1. I'm sorry. So another case namukku ivide endana, we are just having a single possibility. So that is between I is equal to 4 and R is equal to, that is R is equal to 3. That is V3 and V4 ne connect cheyan vendi oru single edge vechi connect cheyanam, and there is only a single possibility. appo nammal nokkumbam satyana V4 um V3 um thammil connect cheyan vendi namukku oru edge vechi maatrame connect cheyanengi ee oru possibility maatrame ullu. There is only one single possibility. And that is what we get from our X. That is what we get from our X. So we can say that, what can we say? That the ijth entry, okay, ith jth entry of your X is said to be equal to 1. Okay, that is said to be true. Okay, that means, what does it mean? It means that, what does it mean? It means the number of edges. It means the number of edge sequences, okay, its sequence of length is equal to 1 between your V4 and V3 is said to be equal to 1. Okay, which is said to be true as we have, which is the edge that we have the edge is equal to, which is the edge that is there, it is said to be what? It is said to be C. It is said to be C. It is because as we have the edge is said to be equal to C. Okay. So that was for your R is equal to 1. Now let us consider, you have to prove till R is equal to 3. Okay. So R is equal to 2 edukam. R is equal to 2 എന്ന് പറഞ്ഞാൽ that is x raised to r which is equal to x raised to 2 which is equal to x dot x. Okay, x dot നമ്മൾ matrix multiplication ആണ് ഇവിടെ ചെയ്യണം. What is the value of x, children? What is the value of x? X value you already remember is that to be 0 1 1 0. Okay, 1 0 1 0 1 1 1 1 0 1 and then you have 0 0 1 0. Okay, this is the matrix you have and you need to perform x dot x. So what is x dot x? What is x dot x? X dot x is equal to 0 1 1 0 1 0 1 0 1 1 0 1 0 0 1 0. Okay, that into again 0 1 1 0 1 0 1 0 1 1 0 1 0 0 1 0. So you have to perform matrix multiplication, that is this row with this column, this row with this column, this row with this column, like that you will have 4 entries. So if you see that element wise നോക്കണം ഈ 0 0 ആണ് പിന്നെ 1 1 ആണ് പിന്നെ 1 1. So 2 ones വന്നിട്ടുണ്ട് ഇവിടെ corresponding same space 2 വന്നിട്ടുണ്ട്. So you can simply write there 2. Okay, അത് കണ്ടിട്ട് ഈ row with this column നോക്കുമ്പോൾ ഇവിടെ 0 ഇവിടെ 0 ഇവിടെ 1. Okay, ഇവിടെ 0. So I'll have it as 1. See, when I do this, I'm correspondingly checking with this elements also. Okay, I'm comparing 0 with 1. So 0 into 1 is 0. Adonai is 0 per line. Okay, so it is said to be 0. This is 1. This is 0. This is 0. So I'll have a 1 here. Okay, pinne midane ivada vachu compare cheyumam 0 0 1 0. So I'll have it as 1. So next you take the second row and you do it with this. What will you get? You will get it as what? Second row with this. So that is 0 0 1 0. So you'll have 1. Then you have 1 0 1. That means 2 1. No? So okay, 2. Next is said to be 1 0 0 and 0. So it is said to be 1. So again you have 0 0 1 0. So you have it as 1. Okay, then next you can just check. I'll just quickly write down. Okay, so this is 1. And then you do it with the second row, you will get it as again, you get 2 places as 1. Then when you do in the third row, that's said to be 3 ones, which is said to be matching with this. So it will be 3 here. And then you have the last one is said to be coming as, that is said to be equal to 0. Because you can see, if 1 adding it is 0 on. 0 on. Pinna if 0 1. So like that, I can get this value. The last row with all the columns when I do, so I'll get that as 1 or single 1. The second one when I do, I'll get it as 1. The third one, when I do, I'll get 0 0 1 again 0 and then a 0. Abra ella zeros are. In the last one when I say 0 0 1, okay, I get a 1. So this is what is your after matrix multiplication. This is your final x raised to 2. That is said to be a x raised to 2. Now keeping this x raised to 2 in mind, you can write this as v1, v2. Now this is your v1, v2, v3. This is your v1, v2, v3 and this is your v4. Okay. Now keeping this in mind, now you have to start doing the same thing. Okay. So now what you have to write? Now what do we need to do? We need to show that every ijth entry in x raised to 2 is the number of the different edge. Okay, the different edge sequences of length is equal to 2 between what? Between your vi and vj. Okay, now I'll take the first example where my I is said to be 2 and my j is said to be 3. So if you see now you have to please remember this is the matrix that you have to see. You will not look into x, you will look into x squared. So you have to check v2 and v3. Okay, what is the entry for v2 and v3? That is said to be equal to, it is said to be equal to 1. Okay, it is said to be equal to 1. So how many edge sequences are said to be possible? That is the number of your edge sequence. Okay, your r value is said to be 2, children. So the number of edge sequence of length, because r value like length depends on another, length is equal to 2 between your v2 and, we took it as v2 and v3 is is said to be V2 and V3 is said to be equal to 1. So which is the path that will we have? What is V2 and V3? V2 and V3 of length how much? 2 ആണ് നമ്മൾ പറഞ്ഞിട്ടുള്ളത് and ഒരു possibility ഉള്ളൂ എന്ന് നമ്മൾ പറഞ്ഞു. So they are saying that you have to see a path between V2 and V3 which is having a length of 2. So if you see this is of length 1. V2 and V3 connect cheyana, this is said to be length 1. Now if I take this path, okay, that is V1, V2 in the V1, V1 in the V3. If I go like that, I have A and D. So length എത്രയാണ് 2 ആണ്. വേറെ ഏതെങ്കിലും possibility ഉണ്ടോ? I don't have any other possibility. Okay, so I can write it as what? I can write it as the path. Okay, the path is said to be V2 ന്ന് ഞാൻ എങ്ങോട്ട് പോയി? I went to V2 and V3 ആണ് പറഞ്ഞിട്ടുള്ളത്. V2 and V3. So what is the possibility? So you have V2, you have V1, and then you have V3, isn't it? So that is going to be your, which is of length 2, is said to be A and D. It is said to be A and D. It is said to be A and D that we can say. Now we can take another example. We can say like I is equal to 4 and your J is equal to 3. So again I'll check my ijth entry, that is my V4 and V3. V4 and V3 ഞാൻ നോക്കുമ്പോൾ V4 and V3 ചെയ്യുമ്പോൾ it is giving me the value as equal to 0. That means I don't have any path between V4 and V3. I do not have any path between V3 and V4 which is said to be of length 2. Okay, which is said to be of length 2. അല്ലേ? അങ്ങനെ നമ്മൾ നോക്കുമ്പോൾ എന്തെങ്കിലും ഉണ്ടോ? നമുക്ക് ആകെപ്പാട് V3 and V4 കണക്ട് ചെയ്യാൻ വേണ്ടി C മാത്രമേ ഉള്ളൂ അല്ലേ? So V3 and V4 കണക്ട് ചെയ്യാൻ വേണ്ടി വേറെ ഏതെങ്കിലും പാത്ത് ഉണ്ടോ which is having a length of 2? If I want to connect also, is it possible? It is not possible. Okay. So the path, there is said to be no edges. Okay, there is said to be no, the number of edge sequences of length 2 between, what does the statement mean? It means the number of edge sequence of length, okay children, of length equal to 2 between your V4 and your V3 is said to be equal to 0. Okay, that is there is no path between your V3 and V4 which is said to be of length which is equal to 2. Now you have proved for R is equal to 2. ഇതിന്റെ എലിമെന്റ്സും ശരിയാണെന്ന് നമുക്ക് പറയാൻ പറ്റി. Now let us go for R is equal to 3. Now we will go for R is equal to 3. So let us consider R is equal to 3. R is equal to 3 എന്ന് പറഞ്ഞാൽ x raised to 3 which is equal to x into x into x. Or you can write it as x squared into x. We already found x squared into x. So how do you find that? X3 is equal to x squared into x, which you can have, you know what your x squared is. Okay, that is all the diagonal elements you have to see. 2, 2, 3, 1. Okay, it's said to be 2, 2, 3, 1. It's said to be 2, 2. Okay, this is 3 and this is 1. Okay, and I had zeros here. So 1, 1 and 1, 1. Like this was your x squared. And then what about your x? X is said to be, all the diagonal elements are said to be 0, isn't it? And so you will have it as 0, 1, 1, you got 0 here. Then you are said to be having 1, 0, 0, 0. Okay, I saw here also zeros. Here also zeros were there. And then these two positions are 1, 1, 1 and 1. Okay. So you have to do matrix multiplication on this such that you will get it as, you get your V1, V2, V3 and V4. If you do this row into column, you can see that you will get the value as 2, then you get the value as 3, then you get the value as 4, then you get the value as 1. Here also you can see that the value comes to equal to 3, then it comes to 2, then it comes to 4, then it comes to 1. If I go wrong, please tell me. Okay, here it is, I think it is 4. Here also we get it as 4. Here we get it as 2 and here we get it as 3. Okay. I'm just doing that multiplication. Each element I'm just looking and I'm counting 1 plus 1 is said to be 2 like that. In this case it is 1 and then the second case we have 1. Then we have 3 ones coming together and then we have nothing. So this is what is my final one. Now using this, okay, using this I have to do it. For reference I'll simply draw my graph also which I had. I named it as V1, V2, V3 and V4. I think this was A, B, C and D. Okay, so we have the graph also. We have, this is said to be what? This is actually your x raised to 3. That is what you remember. Again, I have to take some cases and I have to prove. That is first, I am going to take my, that is my R value is said to be what, children? My R value is 3. That means I have to see how many possibilities are there, which is between my vertices, which is going to give me a length of 3. Okay, a path of length of 3 between the two vertices. So അത് നോക്കാൻ വേണ്ടി ഞാൻ എന്താ ചെയ്യണം, എക്സാമ്പിൾ എടുക്കുവാണ് I is equal to 2 and J is equal to 3 എടുക്കുക. അതിന്റെ അർത്ഥം എന്താണ്, I am going to see whether between V2 and V3 I can have V2 and V3. They are saying that you have a possibility of 4. Okay, 4 possibilities on the, that means 4 possibilities on the where my edge sequence is of length 3. Okay, I have 4 possibilities where my edge sequence is said to be of length is of length how much, as R is equal to 3. അപ്പോൾ അതെനിക്ക് എങ്ങനെ കാണിക്കാൻ പറ്റും എന്ന് ഞാൻ നോക്കണേ. V2 and V3, V2 and V3 ഇടയ്ക്ക് എനിക്ക് എത്ര പോസിബിലിറ്റീസ് ഉണ്ട്? V2 and V3 4 possibilities of length. R value is said to be equal to 3. R, or you can say the length value is said to be equal to 3. So let us see how can I do it. 3 എന്ന് പറയുമ്പോൾ I can have it like V2. I'll write the sequence, you will understand. V2 ഞാൻ V3 ലോട്ട് പോവാ, V3 ഞാൻ V1 ലോട്ട് പോവാ, and V1 ഞാൻ തിരിച്ച് V3 ലോട്ട് വരുക. So between V1 and V3, okay, you can see that I've made a possibility, I've made a path that is V2, V3, V1, V3 തിരിച്ചു വന്നു. So here എനിക്ക് എത്രയാണ്? V2 and V3 ഇടയ്ക്ക് B, V3 and V1 in the ഇടയ്ക്ക് said to be D, and this is said to be D. So this is the first sequence. I said there are 4 possibilities, so I have to show 4 possibilities. The second possibility എന്താണ്? V2 and V3. ഇപ്പൊ ഞാൻ ഇങ്ങനെ എടുത്ത പോലെ തന്നെ you can take like this also and you can take like this also, അല്ലേ? So you can write V2, okay, it goes to V3, okay, it can go to V4 and then come back to V3. So but end vertices has to be V2 and V3. അത് മാത്രം ഞാൻ നോക്കിയാൽ മതി. So this is B, this is C, and this is said to be V3 to V4 in the V3 ലോട്ട് വരാൻ വേണ്ടി I have my this thing. Now let me take the next possibility. I have taken like this, I have taken like this. The next possibility is what? V1 ന്റെ കൂടെ ഇവിടെ വച്ച് I can do it. From here I can write. Now what is the other possibility that I have? I can have V2, I can go to V1, okay, I can go to V1, then I can come back to V2 and from there I can go to V3. So this is my third possibility. This is my third possibility. That is V2 to V1 is by edge A, V1 in a V2 again edge A, V2 in a V3 said to be B. So I have got the third possibility. Now which will be my fourth possibility? ഇവിടെ തന്നെ എനിക്ക് മൂവ് ചെയ്യാം, അല്ലേ? I can move here. That is V2 in V3 ലോട്ട് പോവാം and V3 in V2 ലോട്ട് പോവാം, തിരിച്ച് എനിക്ക് V3 ലോട്ട് തന്നെ വരാം. Okay, that is said to be B, B and B. So I have found 4 possibilities. Okay, I have found how many possibilities? 4 possibilities of length 3. എത്ര edges വന്നിട്ടുണ്ട്? 3 edges വന്നിട്ടുണ്ട്. Okay, how many edges has come? You have got 3 edges. So the length is said to be what? The length is said to be 3. So I have proved this part. Now if I take another example where I is said to be equal to 2 and J is equal to 4. J is said to be equal to 4. That means V2, V4, V2, V4, V2 and V4 is said to be 1. So I have only a single possibility, okay, single possibility of length 3 between V2 and V4. Single possibility between V2 and V4. So single possibility നോക്കുമ്പോൾ എനിക്ക് എങ്ങനെയാണ്, and that also length 3 നോക്കുമ്പോൾ എങ്ങനെയാണ്? You can simply write from V2 you go to V1, from V1 you go to V3 and from V3 you go to V4. So you can prove it by saying that you have the edge sequence V2 ന് ഞാൻ V1 ലോട്ട് പോവാ, V1 ന് V3 ലോട്ട് പോവാ, and V3 ന് ഞാൻ V4 ലോട്ട് പോവാ. So how many edges are said to be coming? A, B and C. So our value is said to be 3. This is also satisfied. Now let us take the third case where I is equal to 4 and your J is said to be equal to 3. I is said to be equal to 4 and J is said to be is equal to 3. So അങ്ങനെയാണെങ്കിൽ എനിക്ക് എങ്ങനെ എഴുതാൻ പറ്റും? I can write it as that is V4 and V3. V4 and V3. I have three possibilities of length. How much? 3. I have three possibilities. Again, എനിക്ക് three possibilities എഴുതി കാണിക്കേണ്ടി വരും, which is of length 3. Okay, so I know that is this is of length 1, right? Length 3 വരണമെങ്കിൽ എനിക്ക് എങ്ങനെയെല്ലാം possibilities കാണിക്കേണ്ടി വരും? I can simply take നേരത്തെ എടുത്ത പോലെ തന്നെ I can take like this. That is, I am starting from V4, I go to V3, I go from there to V2 and I come back to V3. So what are the edges that is involved? That is C, B and B. Okay, next possibility I can have is ഇങ്ങനെ എനിക്ക് ആവാം അല്ലേ, ഇങ്ങനെ എനിക്ക് ആവാം. That is V4 ഇന്ന് ഞാൻ I go to V3. Okay, then I go to V1 and then I come back to V3. The end edges, end vertices have to be same. അത് മാത്രമേ ഞാൻ നോക്കിയാൽ മതി. C, D, D. Okay, next I can have V4 in, I can go to V3. Okay, from there I go back to V4 and I come back to V3. So here who is involved? C is said to be involved. So I have got three possibilities which are of length 3. Okay, I have got three possibilities which are of length 3. So like that, we have proved for R is equal to 1, we have proved for R is equal to 2, and we have proved for R is equal to 3. So obviously what can you write? For x raised to R, you can write it as x raised to R minus 1 into x. X raised to 3, x raised to 2 into x. X raised to 4 x raised to 3 into x. This is how we write. Okay, and then we have already proved that sequence these are the number of possibilities. Okay, these are the number of possibilities. If you have to find how many edges are set to be between the two vertices. From V2 നമ്മൾ എടുക്കുകയാണെങ്കിൽ നമുക്ക് എന്താ പറഞ്ഞ അവിടെ 2 എന്നാണ് പറഞ്ഞിട്ടുള്ളത്. V2 തമ്മിൽ പറഞ്ഞാൽ you can have it like this. V2 എന്ന് V1 പോയിട്ട് പിന്നെയും V2 വരും. Okay, so it has got 2. If I can have like this also, V2 and V3 പോയിട്ട് പിന്നെയും V2 വരും. This how many of them path I can have it as 2 of the paths I can form. So that is how we are trying to prove എത്ര possibilities നമുക്ക് വരുന്നുണ്ടെന്ന്. So I can generalize and write that if I can do it for R is equal to 1, R is equal to 2, R is equal to 3 എനിക്ക് prove ചെയ്യാൻ പറ്റിയെങ്കിൽ x raised to R is also equal to x raised to R minus 1 into x.